Excellent. Well, let's get started. Today we're going to be continuing with custom tables. It's going to be our last custom tables video for a while. We are going to be looking at cutting out more shapes, in particular shapes with more than 4 sides and adding radii between points. The last 2 weeks we've been looking at custom boring, and as it has introduced us to some pretty cool formulas, these tables allowed us to add more hinges to the doors and ends. Specifically this week, we're going to write a custom table that adds recessed handle cutouts. As with the last few webinars, we won't be doing questions for custom tables. You can leave the webinar at any time by clicking on the red phone button at the bottom of the screen. As I said earlier, we are jumping right into tables today. If you need more background on how custom tables work, you can watch our previous webinars. You'll find them on our YouTube channel. Last time we looked at adding cutouts where we did a 4-sided shape for an LED rebate. We used 5 plot points because the shape needs to be closed, so 0.5 was the same X and Y value as 0.1. Now we know that 0 and 0 is the bottom left corner of the part. A negative value will put the point further to the left edge, or a negative Y value will put the point below the bottom edge. Code M is the opposite edge, so code MY plus will put the point above the top, and code MY minus will put the point below the top edge. Dim3 is the thickness of the material of that part, and defin, and then a number in the brackets, refers to the local properties. We're going to start with setting out our variables. I want to be able to change the height of our cutout and the width of the cutout. We also want the cutout to be centered on the top edge of our doors. As it's an enclosed shape, to ensure that there's no unwanted radii in the top edge, the cutout will extend past the top edge of the door by half the tool diameters, half a millimeter more than the tool diameter. So if the tool diameter is 10 mil, we'll extend it past, say, 10.5, 10.2, something like that. And in drawing properties, in my setup, and then local properties, we're going to tick on 9 and 10. 9 will be set as width, and 10 will be set as depth. And in job setup, we can set that one, say, 200 mil or 220, whatever works. And for now, I'm going to make that one 50 millimeters. Now, of course, you can call these whatever you want. I'm just making it nice and easy for us to understand. And I'm going to go apply and OK. So we're going to start plotting our 6-side shape, so 6 corners, and it will need a 7th point to close the shape. Now we're going to be working in a anti-clockwise direction for this one, and you'll understand exactly why I've chosen anti-clockwise once we get into writing the table. So first thing we need to do is go to our machining custom folder, and I'm going to copy and paste, say, sample file, copy and paste, and I'm going to rename that to, let's say, we'll choose handle cutout. We open that up, and I'm just going to select everything because we don't need any of that. We go delete, then we can take these ones here, copy that, and paste them in there. Makes everything nice and uniform. It looks neat. So we know from doing our previous videos in custom boring and whatnot, that lines 1 to 10 are for boring, and then lines 11 to 20 are for our custom shapes. So we're going to start on line 11, and for the use layer, that's 1, so that's on. Our layer can be for now cut out. We don't have a diameter, so we don't need one. Depth. Now we know that dim3, if I can find it, is the thickness of our material. So we could say depth is dim3. But we also want it to penetrate that extra little bit, just like the border of a part does. So if we go dim3 plus, and it is Mac penetrate I've got to spell this right, non-carc. So that value or that code, that comes from the drawing properties in Machine General, Tool 2, and this is where we have our penetration depths, and it will be all other materials, that one there. If we hover over it, we can see that it has enter a length in this edit box for Mac penetrate non-carc. So it is that last bit of that code that we're entering in. If this was going to be a custom table applied to carcass, we could go Mac penetrate carcass. As this cutout is going to be centered, we need to change that to a string, so I need to type that in again. dim3 Mac penetrate non-carc. Perfect, and we'll double click that so we can see it. A lot of these are going to be strings, so bear with me if I accidentally forget one. I'm going to try and remind myself to change it before I type anything in. So as this cutout is going to be center of the top edge of the door, all the X values are going to be calculated from the middle of the door. I'm hoping that makes sense so far. So we'll be calculating from here across and from here across. Imagine this gray line is our door edge, and then this is our cutout. So our X values are going to be the middle of the door divided by 2, essentially, and then allowing for the width of our cutouts. The Y values are going to be calculated from the top edge. So everything will be from the code in Y up or code in Y down. So the first X value is going to be half the width of the door minus half the width of the cutout, which we can write as, and this needs to be a string, code in X divide 2. We'll put all of that in brackets minus another open bracket defin, and we go 9 because defin 9 is the width of our cutout. Except we also need to divide that by 2, just like that. Double click on that so we can see the full code there. The first Y value is the top edge of the door because that's 0.1. So it can simply be code in Y. We're not repeating in any of those. So for now, our Z value can be 0. Z is the radius. We will come back to that later. The next point we're going to work on is 0.4 because it's the same height as it. So it's also going to be code in Y, but it is the opposite direction as 0.1. So instead of being minus, it's going to be plus. So we can simply copy that into our x4, which can be string. And then we need to move to the right column. That's it there. Copy that in there. And we can turn that into a plus. Now, of course, our y height is the same as 0.1, so we can simply make that 0.1.y. That could be a string as well. From here, we can work out points 5, 6, and 7 because everything works. So we'll work out these ones first, 5, 6, and 7. 0.5 is the same x value as 0.4, left to right, and it will be 10.5 mil higher. So x5 could simply be 0.4.x. And we can go string, and y5 can be code in y plus 10.5 millimeters. And we'll make that one a string as well. 0.6, it's the same height as 0.5, but it's now the same x value as 0.1. So it can be easily calculated as 0.5. If I can type these correctly, 0.5.x, except it's 0.5.y, that needs to be 0.1.x and 0.5.y. And they can both be a string as well. 0.7, it's going to close off the shape. So again, it is going to be just 0.1x and 0.1y. We've already got these here, so we can simply copy and paste. Control C is copy, Control V is paste. Makes it very quick to start writing things when they all reference off each other's points. Now, the Z values for all these for now we'll set as 0. So now the only ones we have left are 0.2 and 0.3. The easy part is done. Now we've got to calculate these two. 4.2, I always want the rise and the run to be an equal. So that's a 45 degrees. So think of it like a staircase. That distance there is the same as that distance there. That distance there, same as that distance there, vice versa. So it's the same for 0.2 and 3. So for x2, it's going to be 0.1 plus the depth of our cutout. So we can write this as, this is the x value, and our depth is, if we remember, looking at our drawing properties, job setup, in my setup is probably better to see it, local properties, our depth is going to be defin 10. So for our x2, we can go 0.1.x plus defin 10. And I missed that, so we have to type that in again. Minus defin 10, perfect, excellent. Now we can click on that. And then x3, it's going to be the same as that, except it's working off 0.4. So we can take that, copy it into there. And that will be 0.4. And I did make a mistake because we're going plus for 0.2. We need to make that one plus. And of course, because we're working from 0.4 backwards for 0.3, it'll be minus. The y values are going to be the same for points 2 and 3. And because we're using a ratio of 1:1 for the run and rise, we can enter 0.1y minus defin 10 for both. So we can simply take that, copy it into there, and turn that x into a y. We'll go string, copy that into there, change that to a string. We can go 0 and 0 for both of those. So we double check what we've done. We've turned it on. The layer is cut out. We're dim 3 plus Mac penetrate non-carc. We have half of the width of our door minus half of the width of our cutout for our first X value. And it is just sitting at the top. That needs to be a string. Then going across, we're around, we're going from 0.1 plus the depth of our cutout, etc., etc., etc. We can file and save that. And if we go into CabMaster, open up a cabinet, go to cabinet machining and then custom, then draw fronts. We can find our handle cutout, tick it on, apply and OK. And then we can see it is there. So that's a handle cutout. I think it's pretty cool. We can go into local properties and we can modify it as we wish at a cabinet level. Apply and OK. And we can see it update live in front of us. Now, of course, because all the tools have a radius to them, you'll never get a perfectly sharp corner down the bottom. There'll always be the radius of the tool there. It should do a sharp corner there. If we go to machining and we look at that door, we can see what we have there is essentially what I have in my picture there. So hopefully now that all makes sense and you're following along and you're understanding what I'm doing. So this could be better. Instead of having it extend up above the door, we could have it cut out the border of the door. So over here, we'll turn the layer into minus border, tab, file and save, back to the drawing, F5. And now we can see that it alters the border to match that cutout. And we can see it doing it there. And I'll turn off our machine view. It's there, and we can view it in textured. I think it's pretty cool. If we apply it to our draw fronts, we can go to handle cutout, apply and OK. There they are there, and they're still working off the default catalog set library properties. Now let's add a curve. It's quite modern to have an angular corner, but I want a curve. I want it to be a bit smoother. So back in the table, in the Z column, I'm going to enter 25 millimeters. And in Z3, I'm also going to enter 25 millimeters. I'll save that. And we go back to CabMaster, and if I refresh that, it didn't update, so we will double check where Z25, Z325, excellent. And F5, enter. It's not updating in that view, so if we go to draw to front, right, we can see what it's doing. This is because our local property in here is set as 50. That means if we look at this cabinet, because we set it as 25 or 20, we'll make this one 25 millimeters. The radius matches the drop, so it will work. We go to machining and we view the door. If I alter this radius, or alter the depth, I should say, you can see that the radius doesn't apply. So we want the radius to match the height of our cutout. So instead of saying a fixed value of 25, we could just make it define 10. Make sure they're both string. Save that back in CabMaster. Refresh that. Now we can see it changes, and it will change depending on what the depth of our part is. We now have a full semicircle. That's pretty cool. So what if we want it to be a smooth transition? So a radius on the top edge here leading into a radius down here. We need to add more points in. So we're going from this kind of shape to this kind of shape. It's all very much the same. We're just adding in 2 extra points. And in doing that, it means that our other points are going to have to move. So what was 0.7 now becomes 0.9, 0.6 becomes 0.8, 5 becomes 7, 4 becomes 6, as we can see there. 3 becomes 4, 2 becomes 3, and then we add in an extra point in there as well. So what we're going to do is in our table, go right to the end, and we are going to copy and paste these 3 here into our 9 columns. Set them as string, and we don't need these anymore because we're turning 0.7 into 0.9. We have to do the same thing for 0.6 to 0.8. That's also string, and we can delete them. 0.5 becomes 0.7, so we can do that as well. Into 7, there we go. We delete those. We can keep looking at this and working it out. 0.4 becomes 0.6. Delete those out. We can see that 0.3 becomes 0.4. That's that point there. We don't put them into the wrong columns though. Make that a string. We can delete them out. Then 0.2 becomes 0.3. I've pasted these ones into the wrong spot. 0.3 becomes 0.4. That one, that one, and that one. You can also copy them this way, Control C, Control V. Haven't seen it do that before, but it's not an issue. And just delete them out. Doesn't make any difference, but it's nice to have it all nice and uniform. And as we said, 0.2 becomes 0.3. So we can do the same thing, copy and paste that one, that one, that one, and that one into our 0.3 and delete them out. So hopefully you're still with me and that'll make sense about how we move our points to add more in. So we should now just have empty columns for points 2 and 5. So if we think about the stairs again, we have a run ratio of 1:1. So 0.2 needs to be halfway across and halfway down to 0.3. We can copy and paste from x3 into x2 like that, and then alter the formula to read 0.1.x plus defin 10 divide 2. So we can put that in brackets, close bracket, press tab, and we can click on that. It's the same process for y2. We take that one there, Control C. For y2, I've got to make sure I've got the right one here. We make that 0.1. In fact, we can take that one, actually just put it in there, make that a y, and make that a minus. So it's 0.1 minus defin 10 divided by 2. And we set our z value as 0. I'm going to save this as I go. And I will also change that one to 0 for now. We will come back to that in a minute. We have another defin 10, which I'll change to 0 as we'll come back to that. Okay, so we have the same process again for x5 and y5, except this time we're copying from points 4. So if we copy that into there, and we're going to go in there, divide 2. Now this can actually be, because it is the same y value as 0.2, we could actually make that 0.2 dot y. And we'll set that one as 0. Go file and save. Now all we need to do is make sure that all our points still match up to what they're supposed to. And they all reference what they're supposed to. So starting with 0.2, it's going to reference 0.1 and 1, so it's all good. 0.3 needs to reference 1 as well. So that would become 0.1. Y4 matches Y3. So 0.4's X value has changed and now needs to match 0.6. Y3. Excellent, I have that there. And Y4 needs to match 0.1. Really, no, it needs to match 6. So that is going to be that's 0.1, and that is plus to fin 10. There we go, file and save. Now, X5 also needs to reference 0.6, which currently it doesn't. So we go 5. Actually, let's go back and double check this. 0.4 needs to reference off 0.6, so it's negative and negative. So it's 0.6x minus to fin 10, 4.4, and that is 0.6y minus to fin 10. That will do nicely. 0.5 needs to reference off 6 as well, so we have that in there. 0.5 can still match 0.2. X6 is going to be on the Y1, which is correct, and it is the width of the door, or half the width of the door plus half the width of our cutout, which is correct. This should all be correct because it all just moved across. We will double check. X7 needs to have the same X value as 0.6 now, so that one would be that one. The Y value can stay the same. X8 needs to match 0.1, which it does, and Y8 will match 0.7. So our Y8 for the height matches 0.7. Hopefully this all makes sense. I tried to not make it too confusing. And 9 closes off the shape, so we'll file and save that. If we go into CabMaster and refresh our drawing, we'll grab another cabinet and we will apply our custom table. Apply OK. There it is there. It looks exactly the same, but now we have a point there and there. If we look at our machining and we go door 1 left, we should have a point just there, which we can see if we click on it. Perfect. That's exactly what we wanted. So now we're going to apply radiuses from this point round to there, that point round to there, and vice versa, and opposite on the other side. So that's going to be points Z1, Z2, Z4, and Z5. So we'll go back over to here. Z1, we're going to go define 10 divide 2. And we're going to copy and paste that into Z2, Z4, and Z5. We'll save that and I'll show you what it does. Always refresh. We'll open that up and we'll look at our door. You see currently what it's doing, I scroll back to door again, it's applying a positive radius to all of them. 1 and 5 need to be set as negatives. Negative and 5 can also be negative. You can go file and save that one more time. Refresh our drawing. And we can see that we now have our radius is applying. And we can view that in a 3D wireframe, or if we want 3D textured. And because it all calculates off these two here, we can apply that. And it adjusts the radius for each corner accordingly. That's pretty cool, except we can still see our rail through the cabinet. That doesn't look good. What we could do is move the rail back, or we could also apply a very similar cutout to our rail. That's easy enough. All we need to do is take 11 and apply it to 12. And then we alter the use column so it only applies to the rail and the door accordingly. So in line 11, if we make this if sec part name equals DOR for door, close bracket, then 1 else. We also want it to do drawers as well, so we'd go if open bracket sec part name equals DRW for drawer, close bracket, then 1 else 0. So if it's a door or a drawer, then on, otherwise off. And I didn't change it to string, so we need to type all that in again. Sec part name equals door, close bracket, then 1 else if sec part name equals drawer, then 1 else 0. Okay, we've got that right this time, and it hasn't disappeared on me. We can copy and paste this one into here, and we can break it down a bit. This one just needs to be rail, which is RAL. We can go file and save, back into here. Of course, we need to apply this to the rail as well. We can turn on 3D wireframe so we can see our machining, machining, and then custom. Choose our rail, find handle cutout, and what we'll see is it applies to the wrong side of the rail. Not an issue. All we need to do is in line 12, instead of being Y, instead of the Y values being code in Y, we can now be 0. So we change that one there to 0. Then any value that was minus y becomes plus y. So we can go through here, go plus, and of course it's only for line 12 because we're currently working on the rail. And then finally for y7, that becomes negative 10 millimeters. Because we flipped the y values, we also need to flip the radius values. So that one becomes a positive, that one becomes a negative, that one becomes a negative, and that one becomes a positive. So go File, save that, and we can check if we've done it correctly. There's our cutout there. We could make it a little bit wider, and we can do that quite simply. We could make it wider by a set value, or we could say by the radius. So we'll just add or minus defin 10 off that point there. Z2, yep, we've done that. And then X6, which is this point here, gets plus defin 10. X6 in that one plus defin 10. So what I'm doing is saying it's going to be the same as our cutout in the door. If we go back to our 3D wireframe, it's going to be the width of this cutout plus the width of the radius, or the width of our depth of the door. So that you can't see any of the rail straight up behind the door cutout. You can refresh that. You can see now it makes it a little bit wider. Looking straight on, if you're looking down, it's going to look a lot cleaner. It's not going to have the radius from the rail directly behind the cutout. Now, if you're doing an entire job with this cutout, you only want to apply to base cabinets. It's not going to apply to a wall cabinet because you just have your doors hang down and use your finger pull that way. Tall cabinets, you might apply your own routing in the middle of the door, or you might still put handles or push to opens, tip-ons. So you really only want this to apply to base cabinet, drawer fronts, and doors. So we can then go and modify our use column. And we can alter what we currently have as if sec part name equals door, then one, else if sec part name equals drawer, then one else 0. In each of these, for that, we're going to put and at the start. So we're going to go, if it's a door and, comma, the type is floor, type is floor. So if it's a door and it's a floor cabinet, then 1, otherwise 0. And we can also put that in here, if and comma type equals floor, then one else 0. And of course, we can also put that into this one here. Type equals floor, then one else 0. So now it's only going to apply to floor cabinets. Line 12 only applies to rails in floor cabinets, and line 11 only applies to doors or drawer fronts in floor cabinets. So we can close all that. I'm going to delete that cabinet. Now we can set this table up as a system table, which means it will apply to the entire job. And to do that, we go to Mac Parts, System Table. I'm going to choose the rail first, tick that on. We don't have it in there yet. So these tables, we copy that into System, so it's in the machining custom system. We're going to drop it into door and paste, and drop it into rel and paste. If you do need to know in the table specifically where that set part name rail or door comes from, or what it would be for that part, you have those here. So they're now copied in. If we go into CabMaster, we'll run drawing properties again. There we can see handle cutout. In rail, there's handle cutout there. We can go apply and OK. We should be able to open up a new cabinet now. And it hasn't applied. Drawing properties. It is ticked on. I'll select something different, apply, and select it again, and do the same thing for door, apply, and OK. Put it in, and we can see that it is not machining or applying it at the moment. They are in here, and we have handle cutout. Click on reset, it's not showing. So now we need to work out why it's not showing. We'll come back to that in a minute. For now, let's go back to our custom table and apply that. And we can see that that one does apply. So we know it's not our custom table. It is how it's applying through the system table. Exit back to there. Sorry, I want custom. And we want handle cutout. That should all be correct. Exit. Go blank, apply, OK. Go into details, into there. Meaning system table, reset all, handle cutout. It is simply not applying to our parts. Apply and OK. Machining about door one left. OK. What we can do when we can start troubleshooting why our tables aren't working can open up our table, copy and paste what we have in there, and then set them both as one, file and save, and then we can see if it now applies to our door. There we go. Drone properties, so we can look in here and we can go, what is the problem with our table? Zero and zero, file and save, exit. Back to there, back to door. And it simply will not apply. We know that it is something in the use column. We want door, edit, double click on that. So we can go if and sec part name equals door, type floor, then one, else if and sec part name is draw. If and sec part name equals door, type floor, then one, else if and sec part name equals, then one, else zero. Somewhere in here I have a incorrect formula. So we can simply break down what we have. And it's quite possible that that was the problem. Back to there, apply and OK. Open up that and go door. There we go. That is working again. And if we look at our rail, it's applying in. That is a excellent example of why the codes need to be absolutely correct for custom tables to work correctly. So if we go back to our handle cutout, we can open that up. The issue was these here. I believe. File, save, exit, Control C. Into system, we can replace the ones that we already have in there. Refresh that. Go to 3D wireframe. And there it is there. For our rail and our door. Excellent. If we take a drawer cabinet, drop that in, and there are our cutouts. And they are completely aligned with our drawing properties. So if we make that 400 millimeters wide and 25 millimeters, tab, apply and OK. We can see that it all adjusts accordingly when it updates, just like that. And it will machine out at Easy Nest as well. Now, this, or the cutout for the rail, in this configuration, it won't apply to a two-door cabinet. It would just put the rail or the cutout in the middle of the rail, just like that. It's easy enough to write into the code. You could alter the table to allow. You could alter the table to allow for this based on the door quantity. As for getting the cutouts to line up the doors, it's just maths. The important thing is, if we look at a tall cabinet, then we know that it's not going to apply. So if we go for I've scrolled way too far, tall standard, somewhere in here, tall one door, click on that, drop it in. And you can see that it isn't applying the cutout to our tall doors, so it also won't apply to our wall cabinets as well. This custom table would come in handy for doing, say, wardrobe fit outs. If you wanted a full height drawer front without having handles on it, so it could sit behind doors that close. If you do have any further questions about existing custom tables that already come with CabMaster, send an email through to support@cabmastersoftware.com. Be aware, we do only support the tables that come with the default installation. We can give light advice, basic instruction on helping with writing custom tables, but if you do want to look at new custom tables and writing new custom tables, or you have hardware that needs a custom table written, of course, watch all 4 videos. If you can't work it out, you can send an email to tables@cabmastersoftware.com with the information on that hardware, asking for a custom table to be written. I can't give a time frame, but generally we will get back to you with something. Thank you for joining me this afternoon, and have a good day.